In this video, we are going to look at not only can we find Taylor series for functions by composition and multiplication like we have, but once we have these Taylor series, they actually become really nice to work with because they're polynomials instead. So as an example, if we want to find the limit as x goes to 0 of 1 plus x squared over 2 minus e to the x all over x cubed, if we plugged in 0, we would get a form of 0 over 0, meaning this limit is an indeterminate form where, at least for Calc 1, we would need L'Hopital's rule. And we'd actually need to use L'Hopital's rule at least twice to get all the way down to being able to evaluate the limit. I believe we may actually need it 3 times. So instead of using L'Hopital's rule repeatedly, we can also use this Taylor series and turn that numerator into a polynomial, and we know how to do limits of polynomials. So I'm going to replace e to the x with the Taylor series we're given. Minus the series n equals 1 to infinity of x to the n over n factorial, all over x cubed. And e to the x equals that power series actually for all x. So it does not matter if we're looking at the limit as x goes to 0 or any other limit. E to the x equals that power series everywhere. So we can replace it in without any worries. This should also be an n equals 0 to infinity. So that lower bound should be 0. Writing out a few terms of this series because it is a polynomial, keeping everything else the same. A few terms of this series, when n equals 0, we have x to the 0 over n factorial or 0 factorial, that is 1. When n equals 1, we'd have x to the first over 1 factorial, that is just x. When n equals 2, we have x squared over 2 factorial. N equals 3 is x cubed over 3 factorial, plus x to the 4th over 4 factorial, and so on. This pattern keeps continuing. But now that numerator is a polynomial. 2 factorial is 2. So 1 minus 1, we know by combining like terms, those cancel. X minus x cancels. X squared over 2 minus x squared over 2 cancels. Making this limit, the limit as x goes to 0, of negative x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial plus so on, all over x cubed. Everything has a power of at least x cubed. Most things have a power higher than x cubed, but everything has at least that x cubed, so we can cancel that denominator by dividing everything by x cubed and get the limit as x goes to 0 of negative 1 over 3 factorial plus x over 4 factorial plus x squared over 5 factorial plus x cubed over 6 factorial, and so on. Everything here, as x goes to 0, will go to 0, except for this first term that doesn't have an x in it. Meaning this limit equals -1 over 3 factorial, and 3 factorial is 6. So this limit is -1/6. We would get the same thing if we used L'Hopital's rule a couple of times, but instead of taking any derivatives, we just worked with polynomials here. So we can use these Taylor series to treat them like an infinite polynomial to easily evaluate limits. And in the next video, we'll see we can also use it to take integrals.